Hello students, today we are going to discuss Joule's law of heating. As we have discussed in the previous lecture, heating effect of electric current. In that case, we have discussed three formulas. These are the three formulas that we have discussed. Hope you remember. H is equals to VIT, H is equals to I square RT, and H is equals to V square upon R multiplied by T. So Joule's law of heating was given by Joule, as the name is suggesting, and he state that this heating effect or heat dissipated by any conducting material when the current is passing through it will be depending upon how many factors. These are I, R and T, and how it will depend, it will depend according to this formula basically. So in that case, if we consider a conductor having resistance R, and if we apply potential difference V across this conductor, then amount of current flowing will be I, suppose. And for what time this current is flowing? This current is flowing for time t. So if these are the parameters that we consider, then according to Joule's law, it states that the heat produced or heat dissipated in any conducting material or a resistor or any component will be depending upon, first, the square of current, secondly the resistance of the conductor, and thirdly the temperature. And how it is depending? It is depending directly proportional. So if we want to state this Joule's law, how will we state? It states that amount of heat produced in any resistor due to flow of current through it is directly proportional to the square of the current. H is proportional to I square. Mathematically we can write it like this. Secondly, resistance for the given current, H is directly proportional to R, and the time t, H is also directly proportional to time t, and this time is the time for which we are using the device, or for which the current is flowing through that device or a resistor. So combining all these three factors, we are getting this equation, that is H is equal to I square R multiplied by T. Our next topic related to heating effect of electric current is its practical applications. As in the previous video, I have discussed little bit about the devices which are based on this heating effect, which are utilizing this heating effect are like electric iron, electric toaster, electric heater, electric oven, etc. These are the devices. And there are some devices also I have discussed that are not requiring heating effect. That means the heat dissipation is undesirable in those devices. But practical applications of heating effect is discussing only those devices which are utilizing the heating effect in those devices, right? In these devices, basically in detail we are going to discuss 2-3 points over here. In these kind of devices, what happens, the coils inside these devices are having high resistance. This is very important, high resistance. How they are having high resistance? Because they are made up of alloy like nichrome, which is an alloy of nickel and chromium. Alloys, as we already know, that they are having high resistivity values as compared to its constituent elements, like nickel and chromium are having less resistivity values as compared to nichrome. So if they are having high resistance, what will happen? As we have discussed, that according to Joule's law, that H is directly proportional to I square R and T. Okay, so what happens, resistance is directly proportional to the heat dissipation. So if the resistance is high, then heat dissipated will also be very high. So that is what is the concept over here. So we are having high resistance of the alloys, so large amount of heat will be produced or dissipated through that kind of device, and that heat we are utilizing in heaters, in ovens, in toasters, and in irons, and in many other devices, right? Secondly, we are having electric bulb. Electric bulb as a device that we have to understand according to your syllabus. So what kind of electric bulb? We are having electric bulb which is a filament bulb, that you all know, that filament bulb that we have we were using in the previous years, long back. Nowadays we are not using this kind of filament bulbs, but the concept has to be understood according to the syllabus, according to the device. That is very important. This filament bulb is having a filament which is made up of very thin wire, and it is a metal known as tungsten, right? And inside this bulb we are having a gas which is chemically inactive gas, that is nitrogen and argon gases are used for that, right? So why we are using it, we must understand it. Filament bulb is basically giving us light energy. We are not using its heat energy. That is the point that must be coming to your mind here. Because heating effect in devices, we must understand those devices that are giving us heat, or heat has to be utilized over there in those devices. But in electric bulb we are not utilizing its heat, we are utilizing its light. So what is the concept over here? The heat generated through that electric bulb filament is uh, converted into light energy, because it becomes so hot, so red hot, that it will become it will emit light. That is what is written over here. You can understand this sentence: the filament of a bulb retain as much of heat generated as possible, so it gets very hot, and it emits light, right? So what are the two things that we have to remember about this bulb, electric bulb, filament bulb? Is first is tungsten metal. It is having filament made up of tungsten metal. And why this metal is used? Because it is having high melting point, that is why we are using it. And it is having high mechanical strength also. It is a very strong metal. And this I told you just now that this filament wire is very thin wire, as you must have seen in the filament bulbs also. You can see this thin wire is very thin. So being a thin wire, what is happening, it is having high resistance also. And this metal is used because of its high melting point. So why? Because when it becomes very hot, then it should not melt. So if the material is having high melting point, it will not melt, even if it is having very high temperature, right? And it will be stronger enough if we are using a very thin wire. So we need a strong metal for that. So tungsten is the metal that we are using in that for making a filament, right? Secondly, the important thing is why nitrogen and argon gases are used over here. So to increase this kind of the filament life, it should not be chemically active to the open air, right? So it is these gases are basically used to uh, increase the life of the filament, right? Next is the concept of electric fuse. Electric fuse is very important concept. It is basically a safety device which we are using in many electrical appliances and in our main domestic circuits or commercial circuits also. How it is working, that we should understand. It is very very important, because whenever this device is connected in the circuit, so what happens, uh, it is connected in series, right? And it consists of a type of metal or alloy which is having appropriate melting point, right? Appropriate melting point. So concept we have to understand first, why it is made up of this kind of metal, and how it why it is connected in series. These two concepts we have to understand. If we understand its working in any circuit, what happens, the current, if the current amount is larger than the device capacity, then what will happen, the device may get damaged, right? And if it is if we don't want the device to be damaged, then we want the circuit to be off immediately. So what this electric fuse is doing, electric fuse is having a thin wire which is having appropriate melting point, and up above the particular temperature it will melt. So what is happening, a current, a particular rating current is decided, and according to the device, suppose 5 ampere or 2 ampere current rating has been decided for a device, right? For 2 ampere current of a device, what we are considering one particular fuse wire, and this wire will be melting if the current of more than 2 ampere flows through the circuit or through that wire. It will melt, then what will happen, it will break the circuit, it will break the circuit, right? So what is important is the device should not be damaged. The circuit is broken, that is giving us the benefit that the circuit will not be having your current flow through it afterwards, after it is broken, right? So how the fuse work, that is what is we have written over here. If in any circuit the current larger than the specified value flows through the circuit, then temperature of the fuse wire temperature increases, and which melts it and breaks the circuit. So this is the reason we are connecting that in series combination, we have understood already. So in series combination, when we are connecting the device in a single line, suppose this is a fuse wire in a single line, then it will break the circuit, then the current flow will stop. So that is why we are connecting it in series, and why we are making it with a metal or alloy with appropriate melting point, so that it will melt properly according to the current rating. This current rating can be any type of current rating, whether it is 2 ampere or 5 ampere or 10 ampere, according to the particular device, right? So these were the three important points according to the practical applications of the heating effect, which is given in our NCERT book, right? Hope you understood these concepts of today's lecture. Thank you.